Hello guys, this is Mislav from the other side of the screen, and today we are going to talk about what is an operating system and why do we need it. Okay, so Wikipedia defines, or Wikipedia, I didn't pronounce that correctly, defines operating system as system software that manages computer hardware, software resources, and provides common services for computer programs. In simpler language, operating system is the glue which enables applications such as Mozilla Firefox to communicate with your hardware. And now you may ask yourself, why would Firefox or Microsoft Word or any other program for that matter have to communicate with your hardware? Well, let's take the example of Firefox. And before we even take the example, let me just clarify these terms. So software are the programs and hardware is your actual physical devices. And now why do we need the hardware? Where hardware is actually the physical things which take electricity and convert that electricity into a result of a calculation. Okay, so that's why we need the hardware, because the software tells the hardware what to do, but we need the hardware to actually perform the operation we told it to do. Okay, so let's get back to the example I started talking about, to the example of Firefox. So let's say we have Firefox here, Firefox. And so it's a piece of software and it's a web browser. Okay, it's if you don't know what Firefox is, it's a internet browser, just the same as Internet Explorer and Google Chrome. Firefox has to somehow display the web page you request. But how does it do that? Well, there are two solutions to that question, that are two answers to that question. The first one is just believing in magic and saying it's magic. But this video should help take some of that magic away. Okay, so think of it like this. Firefox exists on a certain level of your computer. And let's say that Firefox has to fetch some data from the network. And the network is actually not being communicated with directly, but every computer communicates with the network over NIC, which stands for Network Interface Card. But this is just a detail. You can imagine that, we're communicating with the network. And so if Firefox wanted to fetch some data from the network, it would have to tell this NIC, which is again a Network Interface Card, it would have to ask the data. It would have to ask for the data. So it would say like data ? And then if the NIC, which is the network interface card, had some data, it would respond with data, right? So the Firefox would ask, do you have any data? And the network interface card would respond with the data if it has any, or if it doesn't have any, it would not respond with anything, or it would somehow signal to the Firefox that it doesn't have any data. Now, why wouldn't Firefox access your network interface card directly, you may ask? And that's a fair question. There are two reasons for that. It would be very difficult to program software that way. Every software developer would have to deal with low-level hardware, and that would be very tedious. I don't know if you ever wrote programs for low-level hardware, but it's really tedious to write them. I have, and it's really tedious. Also, imagine if someone wrote some code to deal with a certain piece of hardware, and then someone else had to write it all over again for their program. That would mean every programmer has to start from scratch, literally, every time he writes some code. And now let's imagine the second reason, let's imagine you're running two applications, and let's call the second application Firefox 2, which I will abbreviate as F2, and it also has to communicate with the network interface card, for example. Or basically, an even better example, I think an even more clear example is, imagine if Firefox 2 is sending some data, over the network interface card. And let's say that the other Firefox, which is our original Firefox, is also sending some data. So instead of asking, instead of the question mark and asking is any data present, Firefox is now sending data, and Firefox 2 is also sending some data. And in this case, what could happen, and network interface card may not be the best example of it, but imagine that the network interface card has this little piece of it which is called memory. And so let's say that Firefox writes data and that it fills up the memory, right? So this entire little piece of memory, which the network interface card stalls, that it later on sends to the network, is filled up with Firefox, Firefox data. So Firefox data sends the data, fills out this little piece of memory, which is held in the network interface card. And now Firefox 2 is also sending some data. And what's going to happen is that data would be overridden by the Firefox 2 data. Now, there's a lot of cases here. Maybe Firefox starts sending its data, and then midway through, Firefox 2 starts sending its data, and we have this situation where some data is for Firefox 1, some data is for Firefox 2, or whatever. So basically, it would be a chaos. Okay, so basically, we see two problems. Number one, it is very tedious to communicate with hardware directly, and number two, the data, if not properly mediated, could end up mixed together with some other applications' data. And applications are basically everyday programs that you use, such as Firefox, Microsoft Word, etc. And this is why you call the operating system functions to interact with the hardware, or more specifically, this is why the operating system exists. And I'm sorry for these little, lines here. I'm not really completely used to my graphics pad. Hopefully, as this series goes on, I will be more and more competent with using it. So basically, we have Firefox here, and we have the network interface card, or whatever hard disk drive, whatever you want to have, down here. So basically, up here we have software, down here we have hardware. And what we have in between, so we just saw the problems with Firefox communicating directly with hardware. What actually solves our problems is the operating system, or abbreviated OS. So basically, Firefox, instead of communicating directly with hardware, communicates with the operating system. The operating system, on its behalf, communicates with the hardware. And then the hardware somehow communicates with the operating system, telling it its status, is there any data, were there any issues, etc. And then the operating system communicates back to the application and tells it the exact same things the hardware told it, or more or less that. It tells it, has there been any issues? If there was any data, it sends the application the data, etc. Okay? So the operating system takes care of the nitty-gritty details of communicating with the hardware and makes sure that there are no things such as two applications overwriting each other, as we saw in the above example. Or put another way, operating systems are a layer of abstraction that eases programming in the upper layers of abstraction and makes programmers' life more simple. And now this is a very complicated definition. You're like, what? What is this tutorial? So like, bro, what are you talking about? What I'm basically saying, on a very simple term, or on a very simple language, is the operating system is the intermediary between software, and this is software, so this is software, and the hardware. And it takes care of the problems we saw above. Okay? And operating systems are the thing we take for granted today, but they are very, very, very challenging to write or to make or to program. Basically, writing an operating system is super hard. I have never done it, but I imagine it is very difficult since I have written some lower level software and that was hard. So thank you, operating systems and operating system software engineers, for making our life easier. And I really hope, and you will probably never appreciate this if you never write some low level code, which, and by low level, I mean code that communicates very directly with the hardware. You will probably never appreciate how difficult it is to write operating systems, but I do hope that you gained an insight into why do we need them and what problems they take care of. So this is it for this video. Hope I'll see you in another video / tutorial, and talk soon.